Welcome, everyone. Thank you so much for coming out today and listening to this live broadcast. You are signed on to the Precision Digital webinar titled An Introduction to Modbus Communications. This webinar is designed as a basic course. Should be helpful for folks who have to deal with Modbus on a regular or even irregular basis, but who are not electrical engineers or full-fledged experts. Although if you are an expert, certainly we welcome you as well. There's always something to be gained from the fundamentals. General housekeeping today, the most common question people have on their minds is, will we get a copy of the recording and the slides? The answer is yes. Everybody who registered for this webinar will get a follow-up email within 1 to 2 days, which will have a link to the recorded version of the webinar, as well as a link to the slides. And additionally, we'll post the recording and the slides on the Precision Digital website, which is predig, predig.com/webinars. That usually gets posted within 2 or 3 days. So check back there as well. Everyone who's signed on is in listen-only mode. That means you cannot speak to us directly via your microphone or telephone, but we do encourage you to ask questions as they come to mind. The way to ask a question is simply type in your question in the chat window in the lower left-hand part of your screen. And we have 2 sessions planned today, one mid-webinar and one towards the end, where we'll be taking those questions live and answering them as they come in. But you don't have to wait till those sessions to type in your question. Type it in as soon as it comes to your mind. So we'll look forward to hearing those questions. Again, this webinar is being recorded, and everybody who registered will receive an email follow-up with the link to the recording and the slides. This webinar is produced and presented by Precision Digital Corporation. And for those of you who don't know Precision Digital, we develop, manufacture a full line of digital panel meters and associated devices, including many Modbus type devices. We do not talk about the products during these webinars because the webinar is educational about Modbus today. But naturally, if you have questions about products that Precision Digital sells and manufactures, please give us a call. Naturally, we're delighted to discuss the product offering with anybody. Speaking today, my name is Bruce McDuffie. That's me on the right there. And I am your moderator today. I'm with the Precision Digital Corporation marketing team, and I am hailing to you today from Boulder, Colorado. Ryan Shea is an application specialist with Precision Digital, and Ryan is working in the background. He'll be answering quick questions on the chat window that are not scheduled to be answered during the sessions. And Ryan deals with questions about Modbus signals and all types of other process signals and customers all day long. So welcome, Ryan. Ryan's helping us today from the headquarters of Precision Digital in Holliston, Massachusetts. Our expert today is Joe Ryan. Joe is a product manager with Precision Digital. He's got 10+ years of experience with the design, support, manufacturing, marketing. Oops, there goes the train going by too, just when we're doing the live webinar. It's okay. So Joe has experience with Modbus and all types of other process signals, and brings a lot of experience to us today about Modbus. And with that, I'll turn it over to Joe. Joe, it's all yours.
Thank you very much, Bruce. Don't worry about the train. It's no problem.
Okay.
So, first, why don't we take a look at what today's agenda is going to be. This is an introduction to Modbus communications. So the first thing we're going to look to do is really answer the question, what is Modbus? You often hear it referred to as a digital communication protocol or something similar to that. And we'll take a quick look at what that really means. Then we're going to talk about the various protocols, networks, and terminology that get thrown around when Modbus is being discussed. So you'll be a little bit more familiar with what all those terms are that are going to come up when you're addressing a Modbus application. We're going to see how Modbus works. In other words, how does it actually function? There's Modbus masters and slaves, and what does all that mean? We'll take a look at when you may want to use Modbus, and going along with that, the pros and cons of using Modbus. And at the end, we've got a practical case that we can walk through, showing a situation where Modbus was helpful, how it was set up, and what the critical specifications were towards designing that specification. The takeaways that we hope we bring with you, that we hope you bring away from this, are to understand the fundamentals of Modbus, meaning the terms, the different kinds of networks, what is a communications protocol, the basic things that you need to understand to have a comfortable grasp of Modbus. We hope that you'll understand how Modbus works, and specifically how it's different than an analog signal, like most commonly, for example, a 4 to 20 milliamp line. We'll want you to understand the pros and the cons of Modbus as a choice of communication protocol, but also versus those analog signals. And hopefully you'll take away something from the real-world example that will show you some of the advantages of using Modbus when it's available to you. Bruce, you had a few questions.
Yeah, it's always interesting for us to see the makeup of the audience, and I know it may seem for you folks out there that you're the only ones on today, but we've got a couple of hundred people signed on today. So I think it's interesting for everybody to see who's out there, what kind of industry and such, and location. So we've got a few poll questions here, just 3 of them to kick off, and the first question is, where are you located? Are you in the eastern U.S., central U.S., western U.S., Canada, or other? And I'll show the results here as they come in. Just take a second and pick an answer, and we'll see where folks are hailing from. Usually we get the most folks from the East Coast. It usually follows right down the time zones, Eastern, Central, Western. Had a good showing from Canada today. Great. And we'll give it a couple more seconds. Get a vote in. Last chance. Okay. Close the poll. And yeah, looks like good distribution, which always makes it interesting. How about your industry? What is your industry? And just let us know what industry you work in. And I think we've got most of the industries here that we represent. And just go ahead and pick your industry. You can only pick one. I know some of you might work in more than one. Looks like nobody from HVAC today. Oh, there's somebody. Industrial distributors, manufacturing, and consulting engineering. Top 3, as you can see. Give it a couple more seconds. Everybody is represented. Last chance. Okay, I'll close the poll now. And again, a nice distribution. That's always good. That makes the questions more interesting when they start coming in. Last one before we get into the material. And this helps Joe when he goes through the material to temper it if needed. So what is your level of knowledge with Modbus? Are you an expert or wanting to be an expert? You know enough to get the job done. This might be your first exposure to Modbus, and perhaps you're even wondering, what is this modern bus these guys are talking about? Where can I catch it? Some people like that question, I can see. Okay, thanks everyone. Appreciate you sharing your information with us. So a lot of new folks, Joe. A lot of folks who it's the first they've heard about Modbus. And that's good because this is designed as a fundamental course. Last chance to vote.
Yeah, that's really not surprising.
Yeah.
We get a lot of questions about it, which is one of the reasons we're having this webinar. So I can't say I'm surprised to see that people are either muddling their way through it or are really just kind of hoping for the best and trying to do what they can.
Yeah. Okay, well, you're in the right place then, everybody. So let's go ahead and get into the material. Joe, back to you.
So the first question we have to answer is, what is Modbus? Well, Modbus is a digital communication protocol for two or more devices to talk to one another. It's an application layer protocol, and what that means is that it's a system that runs on software on a device. So Modbus does not necessarily define for you what voltage equals a 1 or what voltage equals a 0. It's merely defining for you the software that's executing on some Modbus device in order to function. And we'll talk about why that's important in a minute. It has an open source code, and what that means is that Schneider Electric publishes what it is to have a Modbus device so that they can all talk to one another on the same level. And that's really the reason why Modbus has become so popular. It's something that any manufacturer can design a Modbus device for, or design a device to communicate with. And a Precision Digital Modbus device is going to speak the same language as somebody else's Modbus device because it's all an open source protocol. Everyone understands how they're communicating with each other. So I said it was a digital communication protocol, so it's worth taking a moment to figure out what the difference is between a digital and an analog signal. An analog signal is what we're all probably most familiar with. Using the popular 4 to 20 milliamp standard, for example, that's an analog signal. There's some infinite number of values that could fall between 4 and 20, because in theory you could have 12.01, you could have 12.02, and in a pure analog signal you've really got any number of decimal places there. And as it's an analog signal, it's going to fluctuate over time. You would imagine a 4 to 20 milliamp signal might. And at any time, it could change to be some other value. The way a digital signal works is that if I were to take this analog signal and convert it into a digital signal, it's going to operate in time slices, or sample times. And it's going to take, at each one of these time slices, a reading of the signal, provide a change of output, and I'm only going to get reading at those individual times. So that's the point at which I'm going to take my sample, or the point at which I'm going to change my output value. And those values are of a discrete number of possibilities. Now, in the real world, if you're talking a digital output, you may be working with an analog digital controller that has 16 bytes, and as a result, the number of discrete levels you get is going to be huge, and you won't really notice it. Where that comes into play is in something like Modbus communications, and I'll talk about that in a second. Sorry about that, I jumped one slide too far. So what digital communications does is, rather than having a large number of different values that could be transmitted, it's only transmitting two values at any given time. It's transmitting either a 1 or it's transmitting a 0. And that's how you get these binary 1-0 strings that people are familiar with as far as how computers talk to one another. So to give you some idea, you have what this data signal may look like over here, where it looks like some kind of odd square wave. And really what that is doing is that it's changing the waveform such that on in this case, every falling edge of a digital clock, it's taking a reading, and it's reading these high values as 1s, and it's reading these low values as 0s. And that's really the difference between having something like an analog signal and having a digital communication signal. An analog signal is going to be sweeping over time to all of these different values. A digital signal is a timed 1 or 0 that's being transmitted. And then what the device will then do is string together all those 1s and 0s into first a Modbus message, then into an entire Modbus packet. And now you're using these 1s and 0s, and you're transmitting out a lot of information digitally that the Modbus protocol explains to you how to decode. So a device is going to read those incoming ones and zeros, and it's going to say, okay, well, I've got some start characters here, then I've got a Modbus address, some kind of function code, a bunch of data, and we'll get into what those mean in a minute. For now, it's enough to know that the ones and zeros are detected, they get them stringed together, and that gives the commands back and forth between the different Modbus devices. Bruce, a pop quiz.
Okay. Thanks, Joe. And this quiz is, the way these quizzes work is that as soon as you answer the question yourself personally, then you get to see all the rest of the results. But we don't show the results. We don't show the results until then. In the meantime, I know Joe's breaking up a little bit in his phone that he's using. So while we do the quiz, Joe's going to drop off and then sign in again, see if we can get a better connection. So if everyone goes ahead and votes on this, the question is, and Joe just went over this, which one does not describe Modbus? So which one of these does not describe Modbus? It's a digital communication. It's open source code. It provides a 0 to 1 volt DC output signal. It is an application layer protocol, or none of them, or all of the above do not describe Modbus. That's what all of them means. So it looks like folks are voting. Give it a few more seconds and we'll give Joe a chance to call in on a fresh line.
Actually, I just did that.
Okay, you're back.
I am.
All right. Yeah, you sound better. Good. Okay, I'm going to go. We just finished up the quiz. I'll go ahead and close this out, and we'll take a look at the results. And the correct answer is the third one, 0 to 1 volt DC output signal. That is an analog signal, not a Modbus. So it looks like 75% got that one right, Joe. Any follow-up to that
one?
One?
Well, just to make sure everyone understands the answer, though digital communications transmit zeros and ones, those zeros and ones aren't necessarily transmitted on an actual 0 to 1 volt signal. That 0 or 1 is just a communication. It's not the actual signal. The signal itself, excuse me, the signal itself could be a plus or minus 12 volt signal. It could be coming over an Ethernet line. There's a lot of different ways you can be sending those zeros and ones. It doesn't have to be 0 to 1 volt. And as you said, 0 to 1 volt really sounds more like an analog transmission than it does some kind of digital signal.
Okay.
So with that, why don't we jump into a description of some protocols, networks, and terminology about those that you're going to hear when talking Modbus. So we know that Modbus is going to send these digital communications, these bits that are packaged into Modbus packets. The question is, how is it actually going to do that? How does one device send its information to a second device? As I said earlier, Modbus is an application level protocol, which means that it's all about how those zeros and ones get read. It's not about how those zeros and ones get transmitted. And so there's a lot of different ways that physically you can wire up devices to be able to talk Modbus to one another. The most common ones you're going to see in the process industry are RS-232, RS-485, USB, and Ethernet. A great way to think about this is that Modbus really defines the language being spoken. So Modbus is the equivalent of saying, well, I'm talking to you today in English. Now, I could be talking to you in English by a phone line, a voice over IP line. I could be writing English to you in an email. I could fax you something that's written in English. Either way, I'm going to talk to you in English. You're going to recognize my words. You're going to be able to understand what I'm trying to say. But I can do it in all these different methods. And that's what RS-232, 485, Ethernet, USB, that's what those are. Those are just different approaches to get that Modbus data back and forth between two Modbus devices. And because Modbus generally doesn't cover that sort of thing, that's why you have all of these different options available. It's good to have an understanding of what those are, though, so that you'll be aware of the most common ones you're going to see, how you're going to have to wire those, and what the pros and cons are. So if you've got a Modbus device that talks on RS-485, there's 5-wire and 3-wire options there, and it's good to know which one you're dealing with. You can wire a 5-wire device to a 3-wire device, but if you're stuck with 5-wire, you need to know it in advance. RS-485 is a multi-drop network, meaning that you can have multiple devices easily added to it. You just wire them all up in parallel across the same lines. It can travel quite far. 4,000 feet for most applications is pretty sufficient. And I think you're going to find that RS-485 is one of the most common types of networks that's included on serial devices. Now, the big problem with RS-485 is that it's not a common computer-based protocol. If your goal is to eventually bring this RS-485 into some desktop computer in the control room, or you want to be able to use Modbus for device programming in the field and you want to connect it up to your laptop, RS-485 isn't very convenient for that. It's great for field wiring because it's just, in most cases, running 3 wires around to all your different devices. But getting it into a computer is going to require some other kind of adapter or input card. RS-232 is almost the exact opposite of 485. It's a standard for older computers. You probably recognize the connector that you see there on the right. And COM cables, which are what you use for this mostly, are pretty common. The problem with RS-232 is that it usually only connects 2 devices. You've got your cable with 2 ends, and it plugs the 2 devices together, and that's that. It's got a shorter range than you get out of RS-485. And so with the exception of the fact that it's more common on computers, you can see why our RS-485 is more common. USB is also possible, Modbus over USB. Everyone's familiar with the different types of USB connectors, and I'm sure most of you have USB connectors of some kind sitting around your desks right now. There's Type A, Type B, Mini, Micro, and they're all essentially just different ways of connecting to USB. But USB, when it comes to Modbus, is really only used for directly connecting a laptop or some kind of programming device. It's used a lot on devices that are going to get programmed on the bench and then installed in the field. Because USB is a very short-range system. It's really only designed to go about 16 feet. It's very common on computers, though, so if you are just looking to connect up directly to a Modbus device for programming, then USB is probably fine. USB is also a great choice if you get a RS-485 to USB adapter, because then you can wire your field devices with RS-485, bring that into your adapter, and then take out USB that connects to your computer. And growing in popularity, there is Modbus TCP, which is essentially Modbus over Ethernet. There's a lot of advantages to that. You've got devices that can be accessed anywhere on the network. Realistically, they can be located anywhere in a facility or even anywhere in the world if it's done properly. There's all sorts of different web servers, virtual COM port devices that allow you to connect up to wherever you need to go. Unfortunately, all of that's fairly complicated. So you have the ease of the fact that Ethernet wire is likely running all over your plant, but to really understand how that network functions and make sure that all of your devices are able to talk over all of the hubs and jumps that it needs to in order to make this work, you need to have a pretty solid understanding of your network topology in that case. Ethernet has one other advantage in that you can get power over Ethernet if you have that capability wired in your facility. And more devices are coming out that are designed to get their functional power off of that Ethernet cable. And Bruce, you got a question for the audience?
Yeah, this question is about how you deal with Modbus, and the question is, what are your biggest challenges, or you can say, what is your biggest challenge with Modbus? And we'll show the results as they come in. And by the way, just to keep everyone updated, we do know the sound is still a little bit choppy, and we're working behind the scenes to try and smooth that out. But hopefully it's not not too bad that it'll drive you away. But we'll just let you know we are working on it. Okay, thanks everyone for voting. We've got the votes coming in here. Looks like the winning one so far is it's difficult to set up, which I think Joe just mentioned. Other things coming in the chat window, it looks like security is one of the biggest challenges. Unfamiliarity with the protocol, just don't know enough. Don says he uses more Profinet than Modbus. Ian says he gets incorrect values in the system. Michael says COM problems. And Randy says not reliable enough. So quite a few other ones we haven't captured here. Thanks for typing those in, everyone. Looks like it's not too expensive. Steve says it's less reliable than 4 to 20. Man on that one, huh, Joe?
That's somewhat true. 4 to 20 is an old, reliable standard, and especially with people who are unfamiliar with Modbus, it can be unreliable when problems start to surface. They're hard to fix.
Okay,
I'm not really surprised by the results here, by the way. Modbus can be difficult to set up, especially if you have a network that has to make a lot of hops through different types of network adapters. And what I guess what surprised me was infrastructure does not support. I guess that essentially comes down to the fact that people have devices that don't talk Modbus, and unfortunately that's a problem. Now, if you wanted to change over to that, you've got to be replacing components.
Yeah.
But
or lack of power maybe in an infrastructure. Yeah. Okay, we better close the poll and move on. We've got a question and answer session come up, but it looks like by far the biggest challenge is that it's difficult to set up. Okay, we've got the break for some questions here, and we have a couple of questions that have come in. The first question is from Alan. He asks, how does RS-422 fit into the communication protocol?
Well, I can't claim to be that knowledgeable in RS-422. It's an older protocol that I don't see implemented a lot. It seems like it's mostly been replaced by RS-485. But RS-422 is essentially just another network type, similar to in that it's the same type of network you'd see with RS-232 or RS-485. It's wires that you can run out in the field and allow devices all to talk to one another. I believe one of the reasons that RS-422 has been somewhat replaced by RS-485, as I've seen in the field, is that RS-232 really wasn't designed to be a big multi-drop system. I know you can do it. I think you can get maybe, I want to say it's 10 or a dozen receivers tied together for it. But in a lot of ways, RS-485 really has somewhat supplanted it. So if you want to talk about 422, I'd be glad to do it, but I need to do a little bit of research first on that one.
Okay. Thanks, Joe. Here's a question from Vincent. He says, how does BACnet fit into this conversation?
BACnet is essentially a variant protocol, or a different protocol. So you've got Modbus, which defines for you how those ones and zeros in their data packets, how those are interpreted. Well, which of those bits are the address I'm trying to talk to? Which of those bits are my commands? And I'll talk a little bit more about how Modbus works in a moment in that regard. But BACnet's essentially a different protocol. So it's going to have its own descriptions of, okay, how is this going to function? How am I going to react to that? And I without going too much into that, essentially that's what you need to know, is the BACnet's just another version of a serial communication protocol.
Okay, and we've got a question from Steve, and he says, how is power set up for devices using Modbus? I guess, how do they get their power?
Well, it's worth noting that Modbus devices do generally have pretty high power requirements. So you're not going to see a 4 to 20 milliamp loop power device or a 2-wire device that talks Modbus. At least they're not going to be common. It's not going to be a constant communication at that too. So So usually Modbus devices will have to have power provided somehow externally. So you're going to have either AC or DC or potentially power over Ethernet driving them, but it's not going to be a two-wire device. Now that having been said, the device is going to be powered however the device is going to be powered. It could be high voltage, it could be low voltage, it really doesn't matter. Any external power is going to give you enough juice to run your Modbus device. And so there's a lot of different ways so long as you do have some kind of external power.
Okay. Okay. I think we'll take one more question and then we'll move on. This is from Bob, and he says, why do people still like to use an older protocol like this as compared with FF or PA? I'm not sure.
The main reason is that the main reason is that it's out there. Because it's a easily accessible open source protocol, any device that you make today that talks Modbus is going to talk to an older device that talks Modbus. And a wide range of manufacturers can easily produce it. So I think it just comes down to the fact that there are Modbus devices out there, and the best way to manufacture devices that are compatible with those is to make Modbus devices. And so to some degree, it self-perpetuates like that. And yes, there are some people making some comments about Foundation Field Bus and how it communicates. I'm not going to make those judgments now. They all have their place. But suffice to say that once you've got Modbus installed in the field, like for example, it's big in oil and gas, you're going to just continue to see Modbus be propagated there because that's how all these devices stay talking. You don't change your protocol.
Okay. Thanks, Joe. Thanks, everyone, for typing in questions, and continue to keep the questions coming. As said, we'll have another question and answer session towards the end, time allowing. But I think some of the questions coming in now will be answered here over the next section. So, Joe, back to you to continue.
All right. So, in order to understand what Modbus is really doing, you're going to have to understand some of the terminology that's involved with it. And we've got some of those up here on the screen now. You have to be familiar with what a slave address is or a device ID. You're going to have to understand the baud rate, what data formats might be talking about, what the parity actually is, and then you've got a whole bunch of others which probably aren't really necessary for you to set up your system. The first thing that every Modbus device is going to have is some kind of device address. Sometimes it might be called a slave ID, but essentially it's a identifier for it beyond the Modbus network. It's going to be a number between 1 and 247, and it is absolutely critical that each device on the Modbus network gets programmed with its own unique identifier. The analogy here is a room full of people all trying to talk to themselves. If you don't know anyone's name and you can't address anyone by a specific person, then you're just going to have everyone in the room kind of shouting at each other, and people are going to be, it's going to be a mess. You're not going to be able to successfully communicate. However, if every person in the room has a name, and as we'll talk about in a minute, you have one person calling out those names for that person to speak, now you've got a nice organized flow of data. So the device address is necessary so that when a Modbus master sends a request to the network, you can say, hey, device 3, I want you to do this, or I'm requesting this information. And though all the devices on that network are going to hear it, only device 3 is going to say, you know what, it's talking to me, I'm going to reply. So every device gets a unique device address. Baud rate is the speed of communication. So now that you've got all those devices talking, and you can hopefully tell which one is being talked to, recall that digital communications always happens in those time slices, where you check whether it's a 1 or a 0 on the line. Well, if those time slices aren't synchronized between everything on the network, then your communications is going to fail. They all need to be looking at the same speed on the line to read those 1s and 0s, and that's what your baud rate is. You're usually going to see some kind of number between 300 and 19.2. In most process applications, the speed really isn't that important. It's not that critical that your system respond very quickly. But if you have an extremely large number of devices, or you have some problem in your network where you really want to slow things down to help it work better, you may want to either go to the higher or the low end of that spectrum. But usually I find most things are going to operate in around 9800 baud, which is fairly slow in digital communications, but fast in terms of real-world processes. Data format is something that you're going to hear about as you dive into Modbus devices. This lets the devices know what form data is showing up in. So it will tell it that you have one start bit, but some devices are going to have two stop bits, for example. So how does it know when a packet is successfully stopped being sent to it? It's going to let you know what format the data is going to be sent in. Is it an integer or a long, or all of these terms that you're probably familiar with, but are just lookup table items. And so long as all of your devices are properly matched, you don't really have to have a great grasp on what all of that means. All you need to know is that I have a device here that says that it's got one stop bit, so I need to make sure I've programmed all my devices to have one stop bit. And as long as you match all those data format values, then the system's going to operate just fine for you. Parity is another one of those items that needs to match on everything on the network. Parity is going to be set to either even, odd, or none. And what parity does is it defines the part of the Modbus signal known as error checking. Essentially what parity is it's taking the Modbus word, the Modbus data that's being transmitted, it's counting up all the ones, and it's saying, there's an even or an odd number of ones in this, and then it's sending that off to the other device. The other device is going to do the same thing, check and make sure that it matches. And what that will do for you is let you know if you've had a bit error in your transmission. I know that sounds kind of complicated, but let me try to explain it very simply for you, just so you have some idea of what parity does. Imagine that I've got a simple 4-bit word that I'm trying to send. That's 1010. Well, it's going to amend this, and it's going to say, well, all right, I have 2 ones in here, so I'm going to put another 1 on the end of this word, and that's going to represent the fact that I have even parity. Or I should say that's going to represent the fact that I have an even number of ones. And forgive my poor mouse drawing here. Well, if that gets transmitted to another device, and I've somehow had a transmission error, and I now read this, well, when my device reading that signal checks that one that says it should be an even number of ones in the signal, I know that I've got an error because I've got an odd number of ones in my system, or in my word. So it's a very simple way for a Modbus system to detect errors that only affect 1 bit of the signal. There's other error checking that happens as well, but this is one that's programmable. So when you go into a Modbus system, there's very often devices are going to have you set the parity. And you want to have some sense of what that is, and you need to know that, most importantly, they all need to match. And then you've got all of these other confusing specifications you're going to come across. You're going to see things like byte-to-byte timeout. You're going to see things like transmit delays. You might run into something like number of retries before failures. Those are all most likely very useful in very, very specific circumstances. Most of the time, those kinds of parameters can simply be ignored. Your product shipped out with a value there that will allow it to work in almost every scenario. So if you are not a Modbus expert and you see something in there like byte-to-byte timeout, my recommendation is to simply avoid it. Don't make any changes to it, and only address it if you're trying to troubleshoot later. Because more than likely, you're just going to cause yourself more of a headache trying to understand what those things are and how they're going to affect your system and how they match up to the other devices. I'd leave them alone. And I could certainly go into all of those individual examples, but we'll be here for an extra hour. And Bruce, we have another question.
Yeah, another pop quiz. Is this true or false? Modbus allows for unlimited devices on a single network. True or false? Modbus allows for unlimited devices on a single network. And we'll give everyone a chance to choose. A couple more seconds. And last chance. Okay, I'll go ahead and close the poll. We'll show the results. And the correct answer is false.
That is correct.
Of devices.
So, Modbus does allow you to have multiple devices on its network. However, it is limited to 247 devices. And it's limited to 247 devices because every device needs to have its own unique address or identifier. And you can only set that between 1 and 247. So you can have a lot of devices on the network, but it's not quite unlimited.
Okay, let's go ahead and move on then, Joe, into the registers and tables.
So, now that we've talked a bit about the terms that you're going to see in a Modbus system, we really ought to start discussing what you're going to experience when you start setting up a Modbus device and how Modbus is actually functioning at a very high level. So, every Modbus device you see is going to have some kind of Modbus register, table, instruction manual, some usually supplemental document that goes along with it. And that's really where you start to get the data together that you're going to need in order to program up your Modbus device and getting it work in the field. So this register and table is going to have the information you need as far as what is the parity, what is the baud rate. If it can be programmed, it's going to give you the ranges. And then there's going to be oftentimes some massive table in here that can look pretty intimidating, and a lot of this may not mean anything to anyone. So in addition to those other parameters we talked about a bit earlier, I want to take a minute and discuss what the Modbus table is really telling you. So a Modbus device will store its information in registers. A register is essentially just a box somewhere in memory of the device where it's addressed, so it will know that I store, for example, my temperature input information. If I'm a temperature transmitter, I store my temperature input in this box of memory, and I'm going to call that address 40001. So that's where that is, and if anything asks me for address 40001, I'm going to send them the data, which happens to be my temperature information. And what you see up here on the screen at the top is the Modbus table for Precision Digital's own ProView series of panel meters. So if I had this panel meter and I wanted a PLC to be able to extract out the current display value on that panel meter, and I wanted to do it via Modbus, I would need to know, well, what am I asking for in order to get that process variable out of my panel meter? Well, the table is going to tell me that this is the name of the value stored there, so that's what I'm looking for. It's my process variable, or my rate display value. It's going to give me some extra information, letting me know that it's a read-only address. It's going to give me the range of possible values I could return. And that may or may not be useful to me. If all I'm really doing is just pulling this into a computer system, I probably don't need to know that. It doesn't have any units associated with it. Because it's a panel meter, those aren't by default a GPM or degrees Fahrenheit or anything like that. It could be any of those. And so it's got a user-defined unit. But the most important thing here is that it's going to have a register number. And so what this is telling me is that if I want to get the rate display out of my panel meter and into some other Modbus device, I'm going to ask it to read register number 40001 through 40002. It's two registers because its data type is floating point. That's going to require enough bits that it crosses over two registers. So when I go to program my PLC to look at this device and pull out its rate display, I know that as I'm going through my PLC programming, I'm going to know what it is I'm trying to pull out. It's my rate display. I'm going to know the register number that I need to ask for. And when my PLC programming asks for it, I will know that we're talking about a floating point value. So though these tables are long and complicated, they're really just used to look up the specific information you're looking for as you're programming your other devices. So don't get intimidated by the size of them. They're essentially just giant lookup tables. And as you come across these items in the programming of your Modbus master device, your other Modbus devices, you look up to this table to get your answers. Now that I have that information available to me, let's talk for a minute about how this is actually going to work. Well, a Modbus system is made up of a master device and slave devices. There can be only one master on a Modbus system. There can be multiple slave devices. The master is what controls the communication. Thinking back to that example again of a room full of people trying to talk to one another, what Modbus does is it puts one person at the front of the room, and that's the master. And the master is the one who makes all the requests of everyone else and gives everyone else permission to speak. So the Modbus master is going to send down that bus, meaning everybody hears it, some request, and it's going to say, I want address 4 to send me register 40,001 now. And only the addressed meter, or only the addressed device, address 4, is going to respond back with whatever data happens to be in that register. And when my Modbus masters receive that, it's going to execute its next command. It's going to say, okay, address 5, give me some address value, and it's going to have that sent back. Or it could say, device 6, I want you to write this data into your memory register, and it's going to give it the register to write the data to. So the Modbus master is going to control all of that back and forth communication. All of the communication is going to go through it, and it's going to tell all those slave devices when it's going to talk. Slave devices don't communicate without having been given permission to do that by the master device. So you always have to have one and only one master in your Modbus system. Generally, your master is going to be the most complicated Modbus device. If I have a bunch of level transmitters and I have one Modbus scanner, well, I'm probably not doing very much, if any, Modbus programming in those level transmitters. It's all going to get done in the Modbus scanner, and that's going to tell, and you're going to program the scanner to say, these are the device numbers you're going to read, this is the data type of those devices, these are their addresses, this is the register number you have to pull out of it, etc. At most, with the other devices, you're going to be programming maybe a baud rate or an address so that each one has a unique address, and it's fairly simple. Well, where do I get all that information that the master has to request? Well, that's where I look at the Modbus table. That defines all of the data that I'm going to want to program into the master, what the addresses are going to be, what their data types are, what it is I'm going to be requesting of which registers, or telling it to write to what registers. That's all going to be programmed into the Modbus master, and that's all taken out of that Modbus table. When the master and the slaves are communicating, what are they doing? Well, they're using one of those buses we talked about earlier. You send a series of zeros and ones in a data packet back and forth to one another. And what the actual Modbus protocol will do is define what that data packet looks like. So many bits for the address to a meter, so many bits to give it the register, so many bits that hold a function like write this data to a register or send me back this other information, and then a bunch of bits for the data. It ends with some error checking. That format is really what Modbus is all about. It's defining how you read all those zeros and ones to build that complicated communication packet. So that's what Modbus is. It's a master organizing communication to a bunch of slave devices on the Modbus bus. And the Modbus protocol defines how you structure that language that they're talking with the zeros and ones, what the language looks like so that they all know how to react. So that having been said, when do you actually want to use this protocol? Why is it useful? Why do we care about it? Well, Modbus really functions well when you have more than one piece of data passing through a device. Now, that could be because you have a field device that has multiple pieces of information in it, and you want to get them out. Or it could happen because you have many field devices out there and you want to bring them all back to one location. In the case of one device, you may have, say, a multivariable level transmitter. And that transmitter is going to have a top level, an interface level, and a temperature inside of it. Say it's probing the temperature and it's got 2 levels in there. Well, you could get that out by 4 to 20 milliamps, but you're going to need 3 loops to do it. Or you can use Modbus and just ask for all those different registers to be sent back, and now you're digitally communicating out that value. And you're getting the value of all 3 of those values, all 3 of those variables. In the case of multiple devices, you might be using it to read multiple level transmitters or all sorts of different sensors and devices around your process. One caveat to all of this, of course, is that Modbus does require power. So this is really only applicable to systems where you have added power available. If you're running in a low-power solar environment or 2-wire mostly environment, then Modbus probably isn't going to be very good to be used in that kind of an application. So what are the pros and cons of Modbus? Well, there's a lot of pros. You've got the ability to get multiple variables out of individual transmitters or devices. You've got better accuracy from digital signals than you get out of analog signals. Because of all the error checking involved, and because you're only sending 1s and 0s, you don't have as much effect from noise or temperature drift or system inaccuracy. You're getting exactly the number you meant to transmit every time. It's easy to add devices onto a Modbus network. If you were using, let's say, RS-485, all you have to do to add another device is bring the 3 or 5 wires over, and now you've added another device to the network. You program up your master to go talk to that device appropriately, and you're done. As I said earlier, they are highly noise immune. They're excellent for centralized SCADA systems. If you've got some kind of master supervisory system, Modbus is a great way to bring all of that data easily into that centralized system without having to bring dozens or even hundreds of 4 to 20 milliamp loops into that system via some very complicated setup of data acquisition boards. It's open source, which is another way of saying you're going to be able to find a lot of devices out there that talk Modbus. And it's network agnostic. Because it's an application layer protocol, not a physical layer protocol, you can use Modbus to talk over 485 or USB or 232 or Ethernet or a myriad of other possibilities. And you can convert back and forth as necessary from any of those to any of those, whatever you have to do to get the job done. The cons of Modbus? Well, it tends to be more expensive than analog. You've got to get devices that are capable of speaking Modbus, being Modbus masters. Usually those run higher prices than your standard 4 to 20 milliamp style of equipment, at least if you're only doing a couple of loops. Modbus is complex to set up. If it wasn't, most of you wouldn't be here. There's a lot of terminology in there. There's a lot of programming that doesn't make sense to someone who really doesn't understand what's going on or what the areas of or what programming features need to be exactly the same across all the devices and which ones need to be unique. So there's a lot of possibility for mistakes. There's really no way for slaves to report exceptions unless the system is designed to be asked for them. Slaves only talk if talked to. So if you have a poorly designed system, you might miss something that a system based around relays and 420s might otherwise be able to report. And it's limited to 247 devices, which in most cases isn't really a problem. But if it's going to be a problem for you, it's going to be a significant problem because now you've got to support multiple Modbus networks, and that makes things much more complicated. Bruce, another question.
Okay, good stuff, Joe. Here's a quiz, and Joe just went over this. So these are it's the pros. So the question is, which one of these is not a reason to consider Modbus? In other words, which one of these in the list is not a pro of Modbus? Just go ahead and take a moment and pick the one that's the right answer. And again, once you vote, you will, or once you choose the answer, you'll see how everyone else answers. So you can get an idea how you did right off. Give it a couple more seconds here. Still some answers coming in. We're running a little shy of time here, so I'm going to go ahead and close this one out. And yes, the correct answer is that Modbus is not less expensive than analog devices in most cases.
That's
okay,
correct.
let's go.
I'm glad most
people
got that right.
Go ahead, Joe. Yeah, that's good.
I was just going to say I'm glad people were correct on that.
People are paying attention. That's always a good thing. How about this one? What are your primary Modbus applications? You can pick one or multiple applications where you use Modbus. We can look at the results on this one since it's not a quiz. Looks like so far flow is the major one. Temperature, pressure, and humidity coming on strong. We'll give it a few more seconds. And then we'll be able to jump into the example. Thanks everyone for sharing these polling information. I hope you find it interesting as we do. I'll go ahead and close this poll. Like flow, level, temperature, pressure, humidity, so a good mix. Okay, Joe, let's hear about the real life example.
All right. There we go. So let's look at an actual practical case where you might want to use Modbus and what the critical things are you need to know in order to do this. Well, this is a pretty common situation. You've got an operator that wants to monitor the top level, the oil and water interface levels, and the temperature of liquid that they've got stored in storage tanks. Now, this could be at a transfer terminal. This could be at a separator facility. But oil and water do get mixed, and essentially if you allow them to settle, they separate. And so in this application, what they're looking to do is use some kind of mix of transmitters to be able to get out the temperature, that interface level, and the top level in their tank. So how are they going to do that? Well, they're going to use a PD6830X Modbus scanner, and that's going to be their master device. It's going to be the only display device they're going to need for this setup. In this case, they've chosen 4 MTS M-Series multivariable tank level gauges. Each one of those is capable of using a float system to determine the interface level and the top level, and it's got a temperature probe integrated into it. And each one of those multivariable transmitters is going to be a slave device on the network. They're using 3-wire half-duplex RS-485. The advantages of that being that, well, it's easy to wire because you just have to bring 3 wires to each one of these devices. They all just run in parallel on the same bus wire. You can get long distances, so they can definitely get it out to all 4 of their tanks. They've got about 4,000 feet to work with here. And it's a multi-drop protocol, so they can get multiple devices on the network, which they need, not just the 2, because they're going to need 5 devices, the 4 transmitters, and the master. So it looks like this system is planned out pretty well. They have everything they need to make it work. Once they've got it wired and they've got the 485 going to all the devices, they have to program it. So what's their next step? Well, they have the MTS sensor Modbus tables, and they're going to use that to look up their process variable data. A quick look up in the table is going to let me know the location of my level register that contains my level process variable, my interface register, and my temperature register. So now I know as I step through the programming of my Modbus scanner, I'm going to be looking for those registers and which information is going to be in which one. That Modbus instruction manual is also going to tell me there's data type information, some of which I may understand, some of which I may not, but the point is that it's there for me to reference. And it's going to give me this byte order information. And they may not be exactly sure what that means, but that's okay. If it asks for it, if the scanner asks for it, they'll have it available. Then they've got to set up their Modbus scanner. So when they're setting up all of these devices, what are they going to do? Well, they're going to make sure that every device has its own unique address and that includes the scanner itself. A master needs to be one of those unique devices. So they've made the master at address 100, and their tanks are just tank 1, 2, 3, and 4 corresponding with the tank number. Those numbers could be anything, as long as I know what they are, and they're all different. The devices each need to match their baud rates. So if they're programmable, then you make sure they're programmed. In the case of something like these transmitters, if it's fixed, then you just have to make sure your programmable devices match whatever the fixed transmit rate is. So they made sure that everything matched up at the 4800 baud rate. There's this thing called transmit delay, which is specified. And that's a great example of one of those values where, well, not really sure what that is, so why don't we just leave that one alone? Most likely it's shipping from the factory in such a configuration that I only need to mess with it if I have a problem. So I'm going to skip over transmit delay. It's currently 50 milliseconds. Sounds good to me. The system will work fine with that. And lastly, there's configuration for parity and number of stop bits. And in this case, they've set everything equal to no parity and 1 stop bit. And so long as everything in the network is the same, it should all talk appropriately. With their transmitters and their scanner all programmed, the things that need to match, the things that need to be different are all different, and the registers and the data types are all programmed into the master. The master can now request out from a specific address, a specific register, and display that appropriately. So in the end, they've got one device, this Modbus scanner, scanning a total of 15 process variables and showing it on the display. That's the temperature, the interface level, and the top level for 4 tanks. I guess it's actually only 12 process variables, but we'll pretend it's 15. And I was able to achieve that based on some basic, easy wiring, just 3 wires that run parallel to all these devices. My result is noise resistant because it's a digital communication rather than an analog value. It's much harder for noise to affect those zeros and ones than it is just to cause some jumpiness on my analog signals. So it's pretty noise resistant. And I'm going to get exactly what the transmitter is reading every time I ask it for its data. There's going to be no temperature drift. There's going to be no inaccuracies caused by the analog output going to an analog input. It's going to be exactly what the transmitter value is every time. And now my operators are going to have a simple location they can go to that's going to scroll through that information and give them all 12 of those process variables, having to run 12 4 to 20 milliamp loops in any given device. So that's a great way that Modbus was able to simplify this project and make it cheaper, because now instead of having all these different temperature probes and multiple level transmitters, I've got just 4 transmitters, 1 display, and 3 wires that run everything. So as we look to wrap up here, what do I have in summary? Well, we talked about what Modbus is. It's a digital communication protocol for multiple devices to share information. We looked at the protocols, networks, and terms, like what's RS-485, what's 232, what are the advantages of each. We talked about how Modbus works with its master requesting data or sending orders to slave devices and controlling communication on the network. We talked about when it might be useful, when you've got multiple variables you want to juggle in your system, and 4 to 20 just gets too complicated for that, or too expensive. We talked about the pros and cons to keep in mind, and we looked at a basic practical case where Modbus really can save time and money and make the operator's life a little bit easier. With that, we'll use whatever time we have left to take some questions.
Okay, Joe. Thanks. Unfortunately, we're at 12:03, or in Denver here, 12:03, so we're 3 minutes past the hour. And in respect for people's time, what do you think? Do you want to take a couple of questions and folks can stay on if they want to?
Sure. Why don't we take just a couple of questions here? I know there's probably some people that have had questions in there for a while.
Okay, and for those questions we don't get to, again, we'll get back to you after via email, or give us a call. We'll be glad to talk about it. Here's a question from Ed. Ed says, what is the difference between Modbus and Modbus Plus?
Well, Ed, there is a lot of differences. You would think based on their name that they were related somehow, and they're really not. Modbus Plus is a Schneider Electric protocol, But one of the big advantages of regular Modbus is that it's open source, that everybody knows how it works. Modbus Plus is a proprietary protocol that they manage. And it even functions differently in terms of how the networks work. It's not a master-slave protocol. It's a token-passing protocol. It's really an entirely different way of communicating between devices. So that could be its own webinar in its own right. And unfortunately, they really aren't compatible. It just happens to share a name for marketing purposes.
Gotta love the marketing. Here's a good question from Vincent. He says, does the master count as one of your devices? So can you have one master?
The master does.
Okay. Of the 247?
So, yep. So you can really have one master device and 246 slave devices because everything's got to be uniquely addressed, and the master includes that. Because if you think about it, the master is going to need to know if the data being sent up by a slave is meant for it. That will almost always be the case, but it's good to have that confirmation in there. So the master is uniquely identified by an address.
Okay. Okay, thanks again, everyone, for those questions. I think we'll go ahead and wrap it up here since we're over. So if we didn't get to your question, we will get to it via email. And if you have more questions about Modbus, sure, give us a call here at Precision Digital, and we'll be glad to talk to you about Modbus. Even if you don't buy anything, we'll still talk to you. Happy to. Next webinar on May 26th, we're going to rebroadcast the fundamentals of 4 to 20 milliamp current loops. This one was wildly popular, so it's very good basic fundamental information about 4 to 20 current loops. And again, this webinar was presented and produced by Precision Digital. Please consider us your source for digital panel meters, explosion-proof instruments, loop-powered meters, large display meters, pulse input meters and controllers, and more. And of course, any questions about the process signals, analog signals, or digital signals, give us a call. Precision Digital is the expert in that area. Thanks again, everyone. Sorry we went over a little bit. You can get the recording in the email in a couple of days, and you can also find the recording on the predig.com/webinars website. That'll probably be 2 or 3 days. And there's our contact information. Again, happy to discuss our products or, of course, process signals, including Modbus. So thanks, Joe, for the great information. Thanks, Ryan, for your work in the background. And with that, we'll sign off. Thanks again, everyone. Glad you could come out today.